Alright, this video covers Chapter 2, Section 8. The topic is solving inequalities in one variable. What you'll learn about: polynomial inequalities, rational inequalities, other inequalities and applications. And why we're learning this: designing containers as well as other types of applications are often require that an inequality be solved. A polynomial inequality takes the form f of x is greater than 0, f of x is greater than or equal to 0, f of x is less than 0, f of x is less than or equal to 0, or f of x does not equal 0, where f of x is a polynomial. So basically any other case other than f of x equals 0 is a polynomial inequality. So two conditions here, or two possibilities. To solve f of x greater than 0 is to find the values of x that make f of x positive, and to solve f of x less than 0 is to find values of x that make f of x negative. So let f of x equal the quantity x plus 3 times the quantity x minus 4 squared. Determine the real number values of x that cause f of x to be a 0, b positive, and c negative. So for part A, where does f equal 0? Well, we're familiar with this. If we take each of our factors and solve them for equal to 0, we can determine that the real zeros of the polynomial are at x equals negative 3 and x equals 4. And that one has a multiplicity of 2. So what we do is we create this thing called a sign chart. Okay, and here is a sign chart. Basically what a sign chart is just a number line. Okay, and we take a number line and we put reference points on it here and here, and those reference points are our zeros for this problem, negative 3 and 4. So basically what we're doing is we're chopping up the set of all real numbers into intervals. Intervals, in this case, negative infinity to negative 3. Okay, from negative 3 to 4, and from 4 to infinity. We want to see how does this function behave on those three different intervals. And the reason that we break it up there is because we have zeros at negative 3 and 4. So we may have some sign changes of the function at those values, or we may not. It depends on the multiplicity of the zeros. But anyway, if we take a look, part B asks us to determine where f of x is positive. Well, f of x is greater than 0 on the interval negative 3, 4, union the interval 4 to infinity, meaning on these two intervals both, the function is positive. Okay. Now what we do is we take our sign chart, and you can see this little notation here. What we're going to do is we're going to choose a test value from the interval. So choose a value of x that's less than negative 3, like negative 4, and substitute that value into your function and determine each factor whether it's positive or negative. Well, negative 4 plus 3 is negative 1, so that's what this negative represents. Negative 4 minus 4 is negative 8, that's what this negative in here represents. But when we square that negative, that becomes a positive. That positive value times the negative is overall negative. So that's what this negative represents here. Okay? And as long as the value that we choose is somewhere in this interval, this will always be the case. And if you don't believe me, try a different value. Try negative 10 or negative 20 or negative 50. This will hold for any test value in this interval. Okay? Now let's move on to our next interval, negative 3 to 4. The nice thing about this interval, in there we have 0. So use 0 as your test value whenever you can. If I plug 0 in for x into f, 0 plus 3 is positive, so that's where this positive comes from. 0 minus 4 is negative, so that's where this negative comes from. When we square a negative, no matter what it is, we get a positive. Times a positive is a positive, so that's why on this interval we know f is positive. And if we do that same thing, choose a test value greater than 4, we can choose x equals 5, or any other value greater than 4 that we'd like. When we evaluate our function at 5, we get a positive first factor, we get a positive second factor, so overall the value of f will be positive on that interval. Okay, So once we've created this sign chart, really we want to create the sign chart before we even answer the questions on B and C. And so after we've created the sign chart, we know that f is negative on the interval negative infinity to negative 3. So this sign chart, once we've created it, makes it very easy for us to describe the positive and negative nature of the function on these different intervals. Alright, so let r of x equal this rational function here. We want to determine the real number values of x that cause r of x to be 0 and undefined, positive, negative. Okay, so we'll add the undefined nature here because we do have a rational function. So, part A, we want to know where the function equals 0. This is when the numerator is 0. Okay, so we just determine the zeros of the numerator. Pretty straightforward there. X equals negative 3 and x equals 5. Part B, r of x is going to be undefined when the denominator is 0, so just take our denominator and set it equal to 0 and solve. So x equals 2/5 is where our function is undefined. Now we're going to take those three values now and we're going to make a sign chart. So here we have a number line. We have negative 3 as a separating value. We have 2/5, an undefined value, as a separating value, and we have another 0, 5. So we use our zeros and we use our undefined values, all right, to create our sign chart, to break the real numbers up into separate intervals. Okay, and again, after we do that, we choose test values in each interval. So our first interval is negative infinity to negative 3. That's this interval here. If we choose any value in there, this is the sign scenario we get. Negative times a negative over a negative, going to be a negative value. Okay, on the interval negative 3 to 2/5, any number in there is going to give us this situation. We'll have a positive times a negative divided by a negative. Overall, that's going to be a positive value. In our interval 2/5 to 5, any number in there, it's going to give us a positive times a negative divided by a positive. So overall, that's going to be a negative function value. And on our interval 5 to infinity, any value in here that we test, we get a positive times a positive divided by a positive. So we have an overall function value that is positive. So C, where is r of x positive? Well, it's positive from negative 3 to 2/5, anywhere in that interval, or on x is greater than 5. Okay, these two values here, they're those two intervals there. Okay, so here is inequality notation for those intervals. In interval notation, those two intervals would be written this way, parentheses on each one, because if you think about it, the values themselves are not in the intervals. They separate into intervals, but they're not in the intervals themselves. So part D, where is r of x negative? Well, it's negative when x is less than negative 3, okay, and it's also negative when x is between 2/5 and 5. There's something weird going on here with this. So in inequality notation, it would look like this. All right, and then we should be able to write those as intervals as well. Interval notation would be negative infinity to negative 3 and 2/5 to 5. And we would put a union symbol with those because overall it's anything in here or anything in here. Okay? Okay, so another way that we can do this is to solve graphically. And actually this is much more straightforward because we can just look at the picture, and if we are asked to determine where a function is positive, all we have to do is just determine where the function, the graph of the function, is above the x-axis, and if we're determining where the function is negative, we just have to determine where the function is below. So, you know, if we use our technology, we can do this. It's probably much more straightforward, a little less work, but we have to be able to do it analytically too, as those previous examples. So, if we wanted to solve x cubed minus 6x squared less than or equal to 2 minus 8x graphically, go ahead and pause the video and try this on your calculator. And when you're ready, play the video and we'll take a look at the solutions. Okay, so the first thing we would want to do is we would want to go ahead and rewrite our inequality, all the terms on one side. Okay, so this is a situation where we're trying to figure out where our inequality, where our function here is less than or equal to 0. So where is it negative? All right. So we're going to say let f of x equal that function x cubed minus 6x squared plus 8x minus 2 and find the real zeros of f graphically. So we have the tools to do this. And by the way, this screenshot here, this is a screenshot from the TI-84. Ours will look a little different with the Inspire, but our zeros will be at this value, and this value here, and we can get those using our zero tools. So the three zeros are approximately 0.32, 1.46, and 4.21. The solution to the problem consists of the x values for which the graph is on or below the x-axis. So here's our x-axis. So basically any parts of the graph down here will be solutions. So this piece right here and this piece right here. So those intervals. So it's basically, if you think sign chart number line x-axis, it's anything in this interval here and then anything in this interval here. Those x values, those two intervals, are where our function is negative. So since we have an or equal to part, we are actually going to include those zeros in our solution set or in our intervals. So everything from negative infinity up to 0.32 including 0.32, or everything from 1.46 including 1.46 to 4.21, again including 4.21. Any values in there are solutions to the inequality. Okay, so here's a slightly different example. Solving an inequality involving a radical. So here we have the quantity x minus 2 times the square root of the quantity x plus 1, all less than or equal to 0. So how might we go about solving this one? I'll give you a moment to think about that. Pause the video. Think about how you would go about solving this and go ahead and solve it if you'd like, and then when you're ready, play the video. Alright, so we'll let f of x equal the quantity x minus 2 times the square root of the quantity x plus 1. And because of the factor square root of quantity x plus 1, f of x is undefined where x is less than negative 1. Okay, and that's true because if x were less than negative 1, then this would have a negative value. So we would have imaginary solutions. All right. So we're looking for real number solutions. So the zeros are at negative 1 for the radical part and 2 for the linear factor part. So we break our number line up into three separate intervals: negative infinity to negative 1, negative 1 to 2, and 2 to infinity. All right. Now over here we get a slightly different scenario. Everything less than negative 1, we're going to call that undefined. So the function's not defined there, so it's not positive or negative. So we'll just kind of ignore this part. Between negative 1 and 2, the function is negative. And from 2 to infinity, the function is positive. So where is it less than or equal to 0? Well, the answer would be from negative 1 to 2, including negative 1 to 2. Okay, so here are some problems that review what was covered in the lesson. If you want to take a few minutes, pause the video, work these 5 problems out in your notes, and when you're ready, you can go onto the solutions. So here are the solutions to those 5 problems. If you have any questions on these 5 problems or anything else in the lesson, be ready to ask those questions in class. Also, since this is the last section of the chapter, if you take a look at the PowerPoint or the PDF of the PowerPoint for this section, after this slide, there is a chapter test that you can take and the solutions as well. So you could use that as a tool to help you prepare for your test.